Did you actually get your notes out and look at them?
Yes.
Were they helpful?
No.
Did you actually look at them, or did you just sit them on your desk so that it looked like you were looking at them?
No, I looked at them.
Did you talk with your group at all?
She didn't know how to do it.
Claire, you didn't know how to do any of them?
Not number 2. What do you have?
Not which one? Number 2? So she knew how to do 2 of them, but not 1. So you should have been able to at least get 2 of them, Tyson.
Do we want to find a sub for these names?
Thank you. Thank you. Ladies, the whole point of you putting your hand up is to stop talking and signify to others that you're stopping talking. Thank you. Alright. Really? Now is when you choose to do that? So, if the point -3, 5 is translated 5 units right and 5 units down, so notice -3, 1, 2, 3, 1, 2, 3, 4, 5 are up here, that'd be here. That's the point that we're starting at. And so we got a few different answers. I see the point -5, 3, I believe. I see 2, 0. I see 3, 0. And what is that? 5, what is that? What is that? It's hard to learn when we're distracted because we're talking to each other instead of paying attention. I do want to commend some groups. Some groups I saw having the best conversations I've seen in a while. Group 2, Bashar, and I feel like Jalen was involved, but I know I saw Bashar in London talking pretty heavily about the bell ringer. That's what I want to see. Those discussions are going to help you grow and learn, and it's not I'm goofing off or being sarcastic about it. That's what I'm talking about for y'all, because I see some of us talking in nerdy or weird voices because we're just trying to make it weird. That doesn't help you learn and grow, okay? The actual talking about the math helps you learn and grow. What won't help you learn and grow is complaining about not knowing how to do anything. We need to know how to do this. I saw one thing that was very productive from Ireland, where Ireland just wrote down the points and then you were adding and subtracting on your desk, right? Because we should all have this particular note on our lessons from last week. What mathematical operation goes with a translation? Subtraction and addition, right? Adding and subtracting. Anytime that we're dealing with a translation, we should be thinking about adding and subtracting. That's it. If I translate to the right, I am adding. Translating to the left is subtracting. From which variable? X. If it's translated up, it is
multiplying. Oh no.
Adding, and if it's translating down, it's subtracting. From which variable? Y, or value, right? So we got to notice those kinds of things. And by the way, if the parentheses didn't show up, that's my fault. Apparently I didn't check to make sure they were there. But obviously it was supposed to be -3, 5. So if it translates 5 units to the right, what am I doing to my x?
You're adding 5.
Adding 5. Hey, what's -3 plus 5?
2.
2. If I'm translating down, what am I doing?
Subtracting 5.
5 minus 5?
0.
So 2, 0 is where we should have seen our answers. Please note, the values don't just swap. We should never do that. All right, most of us got there. That's at least 20 of us out of 26. I'm pretty happy with that. I would assume the 3, 0 is just a small error or mistake. Are we good with the translating problem?
Yes.
Okay, for those of us who didn't get that, hopefully we're learning from that mistake. So we got the point -2, 7. I think majority of our problem, our thing should be. Hold on 1 second. Let's go up to. We should not be talking. Hold on 1 second. There we go. So we have a few more points there that we should be able to look at. Where translating dealt with addition and subtraction, what do reflections deal with?
Multiplication by negative.
Multiplying by what? -1, right? So those reflections deal with multiplying by a -1. If we reflect across the x-axis, we're multiplying what by -1? The y, which is 7. Remember what we're doing is starting at -2, 1, 2, 3, 4, 5, 6, 7, and I'm reflecting that across the x-axis. So which direction is that?
Up.
Down.
Down.
Which x value or y
It's
value?
y.
That's the y. So we wanted to remember, and I told you all that that's the most common mistake that students make on this, is that they forget, hey, if I reflect over the x-axis, I'm affecting the y. You gotta know that. So, I'm multiplying the y by -1. So I've got -2, what? Not 7, I'm
Negative
reflecting -7. Which is where I get, I'm guessing some people put this one. But was it just a reflection across the x?
No, it was both.
It was both.
So you had to multiply both by negative.
So then, if I reflect across the y-axis,
It's a
if I get it across the y-axis, what about the x?
multiply it by negative.
So then it gives me 2, -7. Tyson, Claire, does that answer your questions on those?
Yes.
Do what? You say something about someone getting lost?
No, he's.
What?
Terrence. Come on, man. Hopefully you don't do that too. No, dude. Don't hit it with your foot and slide it across the ground where you're putting extra pressure on. No, stand up and get it. Those things are expensive. That's how you get them scratched up. They're all of 4 months old at this point. This time. You didn't this time.
I said it.
This
No,
time.
I said did it. Didn't. You know, like
Did not?
no, didn't.
Then.
So did not.
No.
Didn't.
Did something that makes it on the board.
Why are you talking about a dent?
It got a dent in it.
Oh, where?
Oh my God. Right here.
One, you're full of crap. 2, if it does, it's your fault. So don't tell me stuff like that.
I'm telling you,
Stop.
it got a dent in it.
At this point.
Just stop, dude. So, I want to bring up an important thing here because I do want to point out that we've been reflecting across the x and y axis, and that's it. And so only when we're reflecting across the x and y axis does it multiply by a -1. Let's say that I was here, right? And I reflected across, this would be the line y equals 3. If I, no, that's y equals 4. 4. If I reflected across that line, where would my point now be? Would it still be all the way down here?
No.
No? Where would it be?
On that spot.
Positive.
Say that one more time.
3 lines. 3 lines under the line.
There we go. Notice it, remember how it has to maintain that distance? So it's 1, 2, 3 above.
Yes.
So I go 1, 2, 3 below. So I want you to notice that idea of just multiplying by a negative only works when we're reflecting across the x and y axis. That's a small thing I don't want you to miss. Any questions about that? In the future. There'll be questions? Okay. So finally, now we're a little all over the place. I assumed this would happen, which is why I put this question in there. So the point -2, 3 is the image of a point after being translated. Even if I hadn't told you that it was after, how should you know that it's after being translated? It's the image. The image is what you get after, right? The image is what you get after. So it was translated 3 units left and 2 units down, and that's how we ended at -2, 3. So where did we start?
A 3.
Oh.
Oh.
1
-2,
and 5?
Oh.
So you're saying this is what, let's call this A and this A prime?
No.
Yes.
I
No.
thought. No.
Why not? Why wouldn't that be A prime? That's the image, right? The prime goes with the image?
Yeah.
So let's check it. If I translate 3 units left, I go 1, 2, 3. And then what? 2 down, 1, 2.
Oh, okay.
So is 1, 5 correct?
Yeah.
We have to be careful. I heard some people debating about this. How could we have mathematically figured that out knowing that this was the image? We had to reverse it, right? This is where I ended up. So I needed, if that's where I ended after 3 units left, I actually need to go 3 units to the right, so I would add 3. 2 units down, so I had to go back up, so I
Alright.
added 2 units. That's all it was. You just had to reverse the process. Kyson, are you actually paying attention to that, or are you playing with your pencil? It's hard to really pay attention and understand if you're not looking at the board. So, here's our agenda. We already finished up the first page, the exploring transformations. What transformations did we look at on the first page of this TI Inspire task? Actually, go ahead and get your task sheet out, because a whole bunch of us attempted these problems without ever looking at our notes. The thing that we worked on last Thursday and Friday. The same one from Thursday.
Did whole week.
Wasn't a color. It says exploring transformations at the top. Alright, I'm not getting you copies.
Both of them. I just want to back out there. No, right there, no, no. What's the good?
Oh no.
Come on, man, quit playing.
I did it for me and him.
Oh, no, what's your question?
I didn't separate those two. What? You gotta grow up.
Mari, where's your key?
I don't know. My bad. I'm sorry.
You haven't even gotten your backpack out.
I did, look. I kind of.
Yes, sir. Say again. I don't. I want you to focus on the mask. Show our minutes, we get your copies, but I don't think I have any.
Yeah, I got it.
It was to the
I need a ride.
Alright, it's really hard to learn when you lose everything I give you.
You lose every day.
Sorry, you lose half the things I give you.
Barely.
You quit it, but you know, actually unfurl your papers.
Yeah.
did you just shove all your stuff in your backpack?
Part out. You went.
Hey, go this way.
Look at it again, look at it again. I don't have any pictures.
It was.
I'm looking.
I wasn't there for
I
long.
did.
It was on the paper.
Oh, look at that. It's like it was right there. Mr. Kenny, I don't have it.
I ain't even see it. It grew through all the other people,
Alright,
you know that.
so, moving on from that. We are solidifying reflections and rotations with this task. So, what we're trying to do is get comfortable with translating, rotating, and reflecting points, angles, line segments, and shapes. And then we're trying to determine the coordinates of a point or points mathematically after an isometry, a rigid transformation has been applied. The next task we get into is going to formally define this word isometry, which you should pay attention to that because that is one of the main words that is on your Big Ideas graphic organizer. Okay? And I will make this quick note. We have, after this lesson, all of maybe 4 lessons left. So we'll probably have an understanding check middle of this week and a test early next week. So be aware of that. Am I done talking?
No, sir.
It's very rude. It's hot.
Okay, I'll make it cool in a second.
Please don't.
So,
What's wrong with you?
I know I've got 26 students in this classroom, but why are so many talking at the same time while I'm trying to teach you?
Cause they don't want to learn.
Because they don't want to learn. That's the truth.
Well, maybe.
Too many of y'all don't want to learn, and then we sit there and are pissed that we're struggling because we don't understand. Ooh!
What?
Right,
You
right.
said what? You're right about
He
that.
said y'all be
Because we don't
pissed.
understand.
He not.
Say again, sorry. I thought you were saying something. No? So, we started by looking at these reflections from the calculator, which there was a triangle there and it was already reflected, and that's what we saw was exactly what we talked about. Why are you talking, Anton, while I'm trying to teach?
What page is this?
He asked me for my book.
Okay. But focus. I need your eyes up here for now. You can ask her to move it later. So, we talked about the different relationships between the x-coordinates and the y-coordinates of the pre-image and the image when you reflect over the x-axis. So, make sure you pay attention to that. Same thing here with triangle DEF. There's something I want to talk about. I feel like I'm forgetting something. Maybe not. Alright. I believe what we're on was problem 2. Does that sound correct looking at our notes that we made last week? Or is there somewhere that we needed to talk first? Problem 2, this one that's up on the board, quadrilateral ABCD.
Yes, we're on that one because we finished the other one. Is that right? They're moving something here? Huh? They're moving something here?
Problem 2, where it talks about a quadrilateral, rotations. Problem 2, rotations. Yes, Alana.
We on the third
Yeah, where that came from?
Talking about this 1.3 here.
Yeah, I got it.
I don't believe we did, but it's not any different than the other two, right? If it's reflected over the y-axis, we multiplied what by -1? Yes. That's it. You go with that? Do you just really want those numbers written down? No. Okay. It's the same principle, and I will say this, we're going to do one more task with the reflections before we wrap up the unit, okay? So we should be on this problem 2, rotations. So, we're looking at these rotations. Now, rotations are the last transformation that we have not studied. Actually, That is the last isometry that we have not studied. And we'll talk more about what those isometries are later. The only other transformation that we haven't looked at after this is dilations. Rotations you need to pay attention to. Rotations have a rule to them, just like every other one. However, the trick is a little bit harder to identify. With the translations, it was literally just adding or subtracting, right? With the reflections, it was multiplying by a negative. There is still a very clear pattern. Look for what is staying the same, look for what is changing, but there's going to be something a little bit different about this one. So, when we look at the calculator, which I guess I should probably send it back out to make sure everyone has it, is that fair? Y'all can't wait, 20 seconds while I open this up. We gotta start talking.
Gabe, shut up.
Alright. Okay. See, this is what I'm talking about. Like, if we just waited 20 seconds without saying anything to anybody, then none of this would be an issue. Just wait 20 seconds. You're in high school. You're not in elementary school, you're not in middle school, act like you're in high school. So, looking at 2.1, first off, they call this a quadrilateral. Why would they call this shape a quadrilateral?
Because it got 4 sides.
Okay, so it's important to notice,
Yeah, angles.
Actually, quadrilateral is talking about 4 sides.
Yeah.
Okay?
4 points.
It's quadrilateral, again, is about the 4 sides. Will it
Okay.
also have 4 points?
Yes.
Yes. I mean, you can open your eyes all wide and stuff, or you can listen to what I'm telling you and trying to explain. When we say quadrilateral, this part right here is referencing the sides. Not the angles, not the corners, it's referencing the sides
I
specifically.
knew I was right. I knew I was
Okay?
right.
Quad meaning 4. Alright?
Okay.
So, it's okay to make mistakes. What's not okay is for you to start rolling your eyes and giving attitude instead of trying to learn.
Good and
Did
cush.
you hear me on that, Gabe?
Rolling your
Roll your
eyes.
eyes? I didn't even roll my eyes.
So when you look up like this and you go like that's not rolling your eyes, like I feel like that's only rolling your eyes. Huh?
10 seconds.
What?
You can't look side to side. So looking side to side, rolling your eyes.
I mean, going.
Dude, come on. Stop playing. Stop playing. Stop. So,
I'm a little
we're on 2.1. Really quickly, can y'all tell what those coordinate points are yet?
No.
We don't have
Does anyone remember what we did last week to get the coordinate points?
Yes.
No.
You didn't send it out.
You ain't send out nothing.
It does help when I send it, doesn't it?
Yes, it does.
So let me know. Some of y'all still have it on there from last week, but I am sending it again. Go ahead and go to 2.1.
You see?
Yep, I just said it.
No.
What number we on?
2.1
What thing?
on the calculator.
Oh.
2.1. Okay. Don't hit the arrow yet. Don't hit the arrow yet. The arrow. I'll talk about it in a second. Don't worry about it if you don't see it. Because remember, before we rotate it, what do we need? The points for the pre-image. So, I heard someone say hit menu.
Okay.
I got it.
Go to action. Go to menu.
Once I go to menu, what of those operations would make a lot of sense?
Action.
Trying to get the coordinate points? I think we're going to go to actions?
Yes, and go to coordinates and equations.
Yeah.
Number 8.
So, for those of us who did not see that, one more time. Remember, everything runs through menu, actions, and what are we trying to get?
The point.
Coordinates and equations. So, click on the coordinates and equations. Do not forget that when you click on an operation in the calculator, it pops up with this little thing in the top left-hand corner. If you hover over that with your cursor, what does the calculator do?
It brings up a whole
coordination,
explanation.
education.
Brings up a whole explanation.
Yeah.
It's telling us how to use this. Click an object to display its coordinates or equation. That's it. Then you can move the cursor where the results should be positioned so it stays there. Now, since we have so much going on, I'm probably not. Okay, so what are the coordinates for A? 7, comma 11.
Oh.
Right? So I go to my pre-image. Coordinates for A are 7, comma 11.
Okay.
That's it.
Okay.
Now, if you want to, you can click on the object, and then you click it one more time, and it puts that coordinate point there permanently.
Oh.
Right? So you don't have to just hover over it. London, you know how to get these coordinate points?
No, I still
Because you're
don't.
sitting there picking your fingers, and you're not even on the right page. Like, I can only help you so much, guys. If you're not willing to even pick up a calculator, I don't know how you're going to learn. So, does anybody need me to quickly? Gabe, hold. I will come and help in a second. Does anybody need me to go back over how to get those coordinates?
No.
Oh.
We're good.
All right, let's get to work. By the way, if you get done with 2.1, are you going to stop? No, keep going. Work, talk, help each other learn and grow.
Golly.
How you get the other ABC part? How you get to the X axis?